the first column, I'll come on the row alone and the first column and multiply 3 by 2, which is 6, plus 4 by 3 is 12. Then to get D, I'll simply come again and take the row and the second column. That is 3 times 6 is 18, plus 4 times 2 is 8. So that is simply how we add that. Then I'll come and add this. I'll get 8, I'll get 10, I'll get 18, and I'll get 26. So my matrix will be 8, 10, 18, and 26. This will be my multiplied matrix. It's that simple. I hope you followed very closely. If you are lost in the middle, I know you can go back. You can simply tap on your left on your left screen so that you can go back about 10 seconds and get to understand this. Because I simply don't want to take a lot of time, I'll go to the types of matrices so that we move on very swiftly. So, in the types of matrices, think of it this way: the row and column matrix. So we said that we'll think about the row and column matrix. So we're done with this. We're thinking about the row and column matrix. A row matrix is simply a matrix with one row. And a column matrix is a matrix with one column. So if I tell you to give me an example of a row matrix, you just give me a row of numbers like 1, 2, 6, 8. This is a row matrix. And if I ask you for a column matrix, you simply come and give me 8, 10, 24, and 6. So that is simply what we think of. So a row matrix has one row and a column matrix has one column. So on the other note, we'll think about the identity matrix, the square matrix. A square matrix is a matrix with an equal number of rows and an equal number of columns. So an equal number of rows and columns. So I'll say it's a 1 by 1 matrix, it's a 2 by 2 matrix, it's a 3 by 3 matrix, it's a 4 by 4, and any number of rows and that are equal to number of columns. So I'll say that A, B, C, D is a square matrix. I say that 1, 2, 3, 4, 5, 6, 7, 8, 9 is a square matrix. So that is what you can think of when I talk of a square matrix. It's simply a matrix with equal number of rows and columns. Now, the identity matrix is where we'll be moving on. The identity matrix, we can equate it to the number 0. Identity matrix is a matrix that such a matrix that has its diagonal elements, the leading diagonal elements are 1 and all the other elements are 0. So that is what we call an identity matrix. Why is it called an identity matrix? Because if you add this matrix to you multiply this matrix to anything, it will just be the inverse of that. It will just give you the inverse of that matrix. So as we move forward, we'll be thinking about the null matrix. And a null matrix is a type of a matrix whereby you have all the elements of that matrix equal to 0. What do I mean? I mean such a matrix is a null matrix. It's also called a zero matrix. Such a matrix is a null matrix. So in this topic, if you hear of any teacher talk about a null matrix or a zero matrix, this is what we call a zero matrix because it consists of all elements as 0. So equal matrices. Now equal matrices, this is not one type of a matrix. These are two matrices that are equal. Any matrix can be equal to another if at all its elements are equal. For example, 1, 2, 3, 4 can be equal to 1, 2, 3, 4, but it cannot be equal to 1, 3, 2, 4. That is what I mean by equal matrices. So if you ever think of equal matrices, this is what you can come to think of, that two matrices that have each element equal to the other matrix. So element A is equal to element A in the second matrix, element B is equal to element B in the other matrix. So think of that as equal matrices. So objective number 4, we had said that we'll be looking at the determinants of matrices of a 2 by 2 matrix. So what is a determinant? Determinant of a 2 by 2 matrix. So if we think of a determinant of a 2 by 2 matrix, let me give you an example of a matrix that you can come to think of. Think of a 3, 2, 1, 4, and yeah, of such a matrix 3, 2, 1, 4. This matrix can be used to find the determinant. So if you want to find the determinant, you just take elements in the leading diagonal, that is 3, 4, you multiply them, products. The first step is find product of leading diagonal elements. So if you find the product of the elements in the leading diagonal, then you subtract the elements in the other diagonal. What do I mean? I mean, if matrix A, B, C, D, the formula of finding the determinant of this matrix will be A multiplied by D, which is AD, minus B multiplied by C, which is BC. So this is simply how you come to get of the determinant of this matrix, which is, for example, let me go back to what I had given you here, 3, 2, 1, 4. You just come and multiply the elements in the leading diagonal, that is 3 by 4, which is 12, minus 2 multiplied by 1, 2 multiplied by 1, which is 2, and you end up getting 12 minus 2 is 10. So the determinant of this matrix is 10, because we multiplied the elements in the leading diagonal and subtracted the elements in the secondary diagonal. So let's move forward to the inverse of a matrix, of a 2 by 2 matrix. Thinking of an inverse of a 2 by 2 matrix. Thinking of inverse, we simply do it this way. The inverse of a matrix can be found by, we found the determinant of that matrix to be 10. So first of all, you need to find the determinant of such an element, 3, 2, 1, 4. That was the matrix that we used. So if we want to find the inverse of this matrix, we'll simply find, first of all, the determinant to be 10. So I know you can remember how we found this determinant to be 10. Once we find the determinant to be 10, we'll go to the second step. And the second step, so find determinant number 1. Second step will be to multiply. First of all, we interchange these elements of this matrix. The elements of the leading diagonal will be 4, 3. We have interchanged the elements of the leading diagonal. Interchange. And then number 3, what do? You go ahead and negate these elements. If they were positive, you make them negative, and if they were negative, make them positive. So you just, at the position in which they were, don't interchange these elements, just negate them. So they will be like this. So once you are done doing that, that is the matrix that you get. But remember we got the determinant. So what do we do with the determinant? Divide every element of this matrix by the determinant. So you multiply by 1 over the determinant. So you easily get 4 over 10, negative 2 over 10, 3 over 10, and negative 1 over 10. So this is what you get after finding the inverse of this matrix. So this is how you easily find the inverse of any matrix. First of all, you find the determinant. Second, you interchange the elements in the leading diagonal. Then finally, you will go and negate the elements in the secondary diagonal. And after doing that, you will divide by the determinant. It's that simple. So I want simply to solve a simultaneous equation using this matrix method, because I had told you that we can solve a simultaneous equation using the matrix method. How do we do that? Let me give you an example of a matrix. Of a simultaneous equation can be 3x plus 2y is equals to 4, and x plus 4 4y is equals to negative 2. Think of this such a simultaneous equation. How can we solve this equation? So first of all, we'll need to get to put it in form of a matrix, which will be 3, 2, 1, 4. This is the coefficients matrix. This is the coefficient of x is 3, 1, then 2, 4. That is simply how you get the coefficient matrix. So you will get the coefficient matrix, then multiply, get the coefficients, then you will get the constant matrix, which is that. So that is first of all how you arrange this to easily get to find the solution of a simultaneous equation. So after doing this, what do we do next? We go direct to we want to make this to eliminate the coefficient matrix, because we need to remain with this and constant so that we can find the solution of this simultaneous equations. How do we eliminate this? You have to multiply it with an inverse so that we can get what we call an identity matrix. So if you multiply this by an inverse, you'll get an identity matrix, which we said is 0. And after getting 0, we'll remain with the variables matrix, which is x, y, and constants. So we will eliminate it by multiplying and the inverse of this matrix both in this side and in this side. So you remember the inverse that we got. I used the same matrix that we used. So let's do it again. So we got the inverse as this. If you can revisit the other part, we got the inverse as 4 over 10, negative 2 over 10, 1 over 10, that's negative 1 over 10, and 3 over 10. That is how we got the inverse. That is the inverse that we got. And if we multiply it by this matrix, 3, 2, 1, 4, you remember how we said we will be multiplying matrices. You will get a matrix, an identity matrix 1, 0, 0, 1. So that is the matrix that we get. And we'll go, no, first of all, we first write the variables matrix. Then this matrix we want to multiply it by the inverse, so 4, negative 2, and we want to multiply it by the inverse, this inverse. So let's multiply it directly. This is what we'll get, 4 over 10, then multiply it by 4, no, sorry for that. So 4 over 10, negative 1 over 10, negative 2 over 10, and 3 over 10. So you multiply it by this matrix, the